Welcome! The Sun has been producing a remarkable number of flares in the last 24 hours, and this video describes some of those flares and we'll show you some movies of them. Let's have a quick summary of the events. We've had 7 C flares in less than 24 hours. It all started with a C5 flare at 1928 UT on the 21st of May. That was followed by 2 C6 events on the 22nd at 0226 and 0618 respectively. Then a C1 event at 0652. All 4 of those events were impulsive. Then a remarkable C1 event at 0846, which was a long duration event and has gone on for 6 or 7 hours without coming back to background level as yet. Then at 1122 we've had another C2 flare, and then at 1416 another C1 flare. Those 2 were impulsive as well. Now the difference between an impulsive flare and a long duration event is that an impulsive flare only lasts for a relatively short time, a few minutes to a few tens of minutes, and is indicative of a region that is changing quickly or growing. A long duration event usually indicates there's been a coronal mass ejection and we're getting a large number of post-flare loops forming as a result. So here is the light curve from the GOES X-ray instrument. I've marked the C flares on here. But also note that there are a large number of B flares at the same time. Now some of these will obviously be from the region that's producing the C flares, but some of them also might be coming from that region that's just come over the east limb. So when you see the movies, keep an eye on both of them. In fact, you may want to stop the movie and run it again, just so you can look at one region and then the other. Our first movie is a 24-hour movie in Helium-2 304. This sees cooler, dense plasma at about 50,000 degrees Kelvin. Watch for dark material being expelled from the region, both to the northwest and to the southwest. That's the lower and upper right respectively. These are likely the bases for coronal mass ejections. Our next channel is the 171 angstrom channel from the AIA instrument on Solar Dynamics Observatory. This looks at a plasma at about 650,000 degrees Kelvin. That's the lower corona. Note the complex magnetic interconnections between different parts of the region and how they change after each event. Also note the shock waves after each major flare. The best channel to see the flares is the 94 angstrom channel from the Solar Dynamics Observatory AIA instrument. It sees temperatures of about 6.5 million degrees Kelvin, which is much hotter than the normal corona, so thus shows the flares. So let's make some conclusions. The best conclusion from all of this is to expect more flares. Best indicator of flares is to have already had a flare. You could follow more timely updates on my Twitter channel if you wish to follow me there. So until next time, goodbye.